Okay, thank you everyone for sticking around for the panels as well. There's going to be a lot of interesting information. So this panel is called Building with IBC a la carte, and I've got some feedback that people are not necessarily sure what that means. It essentially just means that we have went from the situation where building with IBC was essentially equivalent to using a Cosmos SDK chain. And today we actually see that this is not the case. So there's a large expansion of how you can actually use IBC already today as a builder, right? So first step, we're going to do a round of introductions. But maybe to make it a little bit more interesting, we can also say what your first introduction to IBC was and how IBC impacts you on a day-to-day basis. And let's start from my left. Aditya, go ahead.
Okay, so hello. I'm Aditya. I'm a protocol architect on the IBC team at the Interchain Foundation. So I guess my first interaction with IBC was reading the white paper while I was still a student at Berkeley. And at the time, I was more in the Ethereum ecosystem. I was building an implementation of Plasma. For those who are working on rollups, Plasma was like the hot scalability thing before rollups. And yeah, I read the IBC white paper and the Cosmos thesis, and I just thought sovereign app chains with an interoperability protocol made so much more sense than what I was building. So I got Cosmos built from then. And yeah, my day-to-day life is thinking about IBC.
All right, great.
Yeah.
So all your life is plagued by IBC. How did I get introduced with IBC? Actually, it started with Aditya. He interviewed me. If it wasn't for him, I wouldn't be here. We used to work together a few years back at Interchain GmbH. I first started in Tendermint, and one of the first things I was working on in Tendermint was the IBC, the light client, and the evidence stuff there around basically what is a fork. And unbeknownst to me, that was actually a very core part of IBC. And soon after that, I remember working with Jack Zamplin on one of the very first Go Relay prototypes, which would take basically two light clients. It was only for two chains only, and sort of verify one another, sort of relay messages across. IBC now, well, I just kind of gave my talk on why IBC affects me. I'd like to see just the same sort of shift that happened in the Cosmos ecosystem with the introduction of IBC to have that same effect with rollups, where now we have very reliable way of sort of interoperating between one rollup and another.
All right, and then I should probably also introduce myself. My name is Thomas. I now work at Polymer Labs as a DevRel, but before that I was actually colleagues with these guys. So my first introduction to IBC was also, going through the white paper. I was interviewing with Interchain here based in Berlin. And at the time, I didn't really know yet that I was going to be applying for the IBC team. But when I read the IBC white paper, I was immediately amazed and said oh, this is the right way to go. This is really exciting. And so here we are today. And I would say, how is it impacting me today? Actually, I think we still need IBC to go beyond Cosmos and make sure that people do not associate IBC purely with Cosmos. And at Polymer, one of the things that we're trying to do is to make sure that we have OP stack-based rollups connect to one another via IBC. And there's a lot of education and a lot of just relations with developers that we need to set up, and that is what I'm doing. All right, so great way of introducing. I want to take a step back and have a more bird's eye overview of the industry. And I feel like IBC initially was thought of already in the original Cosmos white paper all the way back in 2016. And then the initial protocol actually took a couple of years to develop. And sort of back in the day, what we saw was, from the industry perspective, a lot of alt L1s trying to launch, Ethereum killer was a popular phrase. And this has kind of expanded to now we see this roll-up-centric world. And so my first question would be to Aditya, maybe as a protocol architect for IBC, Has this, changing landscape actually changed your work as a protocol architect? And does it make it more difficult? Does it mean that you have to go back to the drawing table? Or is it actually that the IBC protocol has held up really well?
Yeah, I think the protocol has held up really well because we never intended for this to be a protocol just for proof of stake blockchains, right? So the initial implementation of IBC contained a Tendermint client and a solo machine client, which was really just a multi-sig. So IBC was never intended to just be a communication protocol between these blockchains. We envisioned that it could also be like single computers, maybe bridges. So the core abstractions reflect that. The clients do not make assumptions about what it's actually verifying. But of course, when you get down to the implementation, then it actually does start to matter that these new technologies have come out. And with rollups, we realized, okay, now we have not just a single standalone client that we have to verify a validator set, but in order to verify this rollup, we need to not just have an understanding of the state of the rollup, but also the state of its underlying DA layer. So that's where we came up with conditional clients to make sure that we can build these more complex verification systems that rely on multiple different ledgers to verify their state.
Right. It's good that you mentioned the conditional clients. I think that's one of the additions to the protocol. And so, yeah, can you maybe explain a little bit more about maybe other things that maybe were thought of initially in the initial design, but have been added along the way?
With conditional clients, or
conditional clients, or maybe something else that has been added recently.
Yeah. So there's been a couple things. So conditional clients is the first one that I'll talk about, which is we used to just have a standalone client where everything about how this client is getting verified has to exist on one light client, and then as we got rollups where there are multiple L2s that are verified against a single L1. We get this problem of, in order to verify each L2, we needed to duplicate the L1 client. So conditional clients were a way to save space and make sure that a single L1 client can be the backbone for many different rollups. At your work in Polymer, the Polymer team has been working on multi-hop connections, which is a way to get packets to route through multiple different hops before they go to their final destination. So right now, all IBC connections are point-to-point. And then maybe in the future, if there's thousands of rollups, that may not make sense. And maybe we do want to route things through the data availability layer or some other hub. So that's work your team has been doing. So yeah, there's been a lot of innovation from multiple different teams, actually, on the IBC protocol.
Awesome. Thank you. And yeah, we know that Callum just had the talk just a little bit before, but also because we will have people joining who watch the recording later. Yeah, I think Celestia is widely seen in the ecosystem as kind of the initiator of the modular narrative. But someone also recently said that, more interestingly, it's also brought the idea of rollups more to the forefront in the Cosmos ecosystem that already has IBC. So maybe just a high-level summary of your talk, how important is IBC to Celestia, maybe the chain, but maybe more importantly, to the Celestia ecosystem of rollups.
Yeah. To go back, I think, a little bit to IBC itself, because I think this relates to Celestia, and also part of the reason why Celestia kind of went with the Cosmos ecosystem to start with, why it chose Tendermint, the Cosmos SDK, and why it continues to want to work with the Cosmos ecosystem, was because, and at first I thought IBC was well over-abstracted, but I actually think that the abstractions turned out to be very sound. I think with these roll-ups and this sort of proof-based system, that's the most challenging change to IBC that I think I've ever seen. It really stretches what the original intent was in terms of proof of stake systems. And I think it's actually held up very well. You've still just got this verification client that is the part only that you need to change of that transport layer, and all the rest sort of still remains the same. As to the sort of Celestia's involvement in Cosmos, yeah, well, we use the Cosmos SDK, and as I said, alluded to beforehand, we like to think of the Celestia state machine as just another roll-up, and so it's actually in our sort of interests, and this is where sort of RollKit comes about, that we sort of push forward the Cosmos SDK into being more sort of roll-up friendly, both to help the Celestia state machine and to sort of help with anyone else coming across that doesn't want to go through the burden of having to sort of find a validator set and all the other sort of extra costs, as well as the actual just costs of running. They can sort of just go straight with rollups.
Yeah, and actually at Polymer, like a lot of this comes together in the sense that as Polymer, we have a Cosmos SDK rollup on top of OP Stack. So the execution environment is Cosmos SDK with the IBC Go, but then ultimately the rollups that we want to interconnect, they could be using Celestia for data availability, and then it's important that we have these conditional light clients that we talked about before to be able to also like prove the data being posted to Celestia.
Yeah, like with modularity, it gets a little bit messy, and I think that's why the conditional clients is very important, because now instead of just relying on one chain as the source of like where you get all your verification from, you're now dependent on like one or two. So you need to first, okay, was the data included on Celestia or any other DA layer? Okay, now was it executed correctly? And so now this two-step process is the sort of like, I think, driving reason why you have these conditional clients.
Yeah, and I think with one light client, it just makes everything much more efficient, because a single header on Celestia could potentially be verifying packets from all Celestia rollups. So whereas before we have every single header from Cosmos Hub only verifies Cosmos Hub packets, same for Osmosis. Here we can massively increase the efficiency of IBC packets by just making one Celestia header validate the packets from all rollups.
Have you thought much about the idea that moving towards this roll-up and having like Celestia, which I sort of alluded to as being this like a community board that everyone sort of posts their data to, could sort of also fundamentally change the use of relayers?
Yeah, I think, well, as you said, for roll-up to roll-up communication, absolutely. Like, so long as you have the same underlying DA, I don't really see a reason for independent relayers, because that can just be the role of the sequencer, right? As you said, each, like a roll-up A to roll-up B packet flow can just be posted on Celestia in a particular rollup A to B namespace, right? And then when the sequencer pulls down the block data for rollup B, it just knows, okay, I'm going to pull down the transactions that are just within rollup B, but also as part of constructing this block, I'm going to pull down the transactions that are sent from other rollups in the Celestia ecosystem to rollup B. So then this message board becomes effectively this single relayer. Yeah, so we can turn Celestia into the global relayer for all Celestia rollups. Absolutely.
Yeah, but definitely today, and there's some people from relayer teams present. They're definitely still important, and we really appreciate them.
Yeah, you still need them from going from Celestia to another ecosystem, right? So exactly. If you're going to the OP ecosystem with Ethereum as the data availability layer or something, you do still need relayers. So. IBC was always intended to bridge across ecosystems and within ecosystems as well.
Yeah, unless everyone uses Celestia for DA.
Yeah, well, you can hope for that feature, but I think we'll always live in a world where there are different ecosystems.
I kind of want to move into like the important conversation of how do we actually expand how builders can interact with IBC. And one of the things that we've now seen is that it's no longer just building Cosmos SDK L1s. You can also use frameworks that allow you to build rollups, and either that is using the Cosmos SDK still as your execution environment, where you kind of like get IBC Go, which is the reference implementation of IBC, kind of for free. But then there's also other ways that you can use it, and another implementation that has been gaining some steam is IBCRS, and for example that is being used in the Sovereign framework, which you mentioned. So that's a framework of building sovereign rollups that use IBCRS and that use Celestia for DA and consensus. I'm not sure like how involved you guys were in the IBCRS story, but probably from a protocol point of view you were somewhat involved. Did the development of like a second implementation, show you something about the protocol that maybe wasn't ideal? Can you talk a little bit about that?
Yeah. So absolutely, we were involved in I wasn't involved in IBCRS from the implementation standpoint, but I was in the protocol calls with the implementers. And yeah, it was critical for us that there were multiple implementations that could speak IBC and speak IBC with each other. Like actually, if you look at the IBC protocol specs, we have a status for every single specification. And we only consider a IBC protocol spec complete if there are multiple implementations that can implement it and cross-communicate with each other. So in a sense, for us, IBC protocol wasn't complete until there was another implementation that could speak with IBC Go. So IBCRS is one example of that. And luckily the protocol didn't have too many issues. Like we were able to speak between IBCRS and IBC Go without having to make any protocol breaking changes to IBC Go. But of course there are, like, as we build implementations with different environments, we just recognize certain shortcomings. Like some places we marshal in JSON, for example, and that might not be very efficient on the EVM. And these sort of concerns that come up where we've made certain technical decisions that made a lot of sense for IBC Go that we're finding are more difficult to make in these different environments. So I don't think from a protocol level there was anything too catastrophic, but just these sort of optimizations and technical debt that we've brought building on Go first that we're starting to unwind.
Yeah, and it's absolutely an important point that, every IBC implementation shouldn't fragment the overall IBC network. You want every implementation to still be able to interact with those other implementations. Maybe as we're moving into the last couple of minutes, this has been really interesting and we could use a lot longer. Maybe, as you can probably see, we were supposed to have Adrian from Anoma as well. He sadly couldn't make it. Yeah. Anoma is kind of like working on an intense protocol. And the first time I heard him give a talk about that, I was immediately thinking, oh, so an intent is essentially saying I want to end up with a certain state. And the way that happens, I don't really care. There's like a solver who makes it happen. But I was thinking, oh, this would be really great in terms of IBC as well. If I can say, I want to end up in this particular state, but it's not just on one rollup or one chain, but it's kind of like, in the IBC network. And maybe this ties into the idea of chain abstraction. Do you guys have any ideas on chain abstraction, or is that not something you've really followed?
At the moment, we haven't been doing anything particularly intent-centric from the IBC protocol standpoint. What we are trying to do is make sure that the IBC applications can be as expressive as possible. So we do just send, from my point of view, like I don't really care too much about what's being sent around. These are just bytes at the end of the day, and I just make sure that they're verified and authenticated as they move around the system. And so I don't see in principle why someone couldn't build moving an intent across the chain. So you say from Osmosis, from the causal sub, you send like a intent to Anoma that then the Anoma chain brings into its solver system. Now, if you want to build like something that is solving across the entire network, that would be like having a unified almost state machine and solving there. And I think that's a much more complex system, and it's one we're just not there yet with the protocol. So I think isolated state machines and isolated systems that communicate across clear boundaries is where we're at. And of course, you could send intents over to other systems, but a full solver system across the IBC network is far away in the future, I think.
Yeah, I guess like one of the hardest things with like these solver networks is you need to be able to prove that it met the intention that you had, right? And I think once you have various different state machines with the different logic, that can be extremely difficult to do.
Yeah, and this would be proofs at a separate layer, right? Because we're talking about, most of the time when we're talking about proofs in IBC, we're talking about proofs at the client level of saying, hey, this proof, this particular packet has been committed. But if we're talking about putting an intent system into an IBC application, then the IBC application itself would be proving that the solver system acted correctly, perhaps in an acknowledgement or something, right? So all of this is possible, but it's just it's adding a protocol on a different layer, and the IBC application is built for that, at least in terms of getting these systems to work in isolation as they want, and then sending the information back.
Awesome. So when we meet again here in 3 to 4 years, we'll still have things to talk about and new things to unravel. And that kind of moves us to the second panel that we're going to have, which is about the non-technical, the non-infra side of expanding IBC. But first of all, I want to thank again our panelists. So Callum from Celestia, Aditya from Interchain, and I was Thomas from Polymer. And yeah, all of the recordings of today, by the way, you can still find on ibcsummit.org, probably real soon. Thank you everyone for listening.
Thank you.
Thank you.